everyone. Thank you for coming out on a Sunday morning. It's my great pleasure to see you all here today. On behalf of ASPJ, which is the Australian Society of British Jews and Their Descendants, and the Australian Genealogical Society and the Australian Jewish Historical Society, it's my great pleasure to introduce you to Jan Gronski, who is actually a doctor, but he'll be cross with me if I say that. While you may not know his name, if you're involved in genealogy, you will have encountered his work. As a key volunteer for Jewish Records Indexing by way of his formidable contribution, working closely with Stanley Diamond by contributing significantly to JRI's databases and digital content. Taking a step back for a moment, I'd like to share some historical moments from Jan's life, which are not that known in the public domain, I don't think. Jan earned his undergraduate degree in mathematics and his PhD at the University of Warsaw and his PhD in mathematics at the University of Illinois. He has a passion for languages, which began as a child of 7. He is fluent in English, Polish and Chinese, with formidable skills in Russian, German and Spanish, with basic comprehension in French and Turkish. Most recently, he's been turning his hand to Yiddish script, which you'll know more about shortly, which he will describe to you. But what I might add to that formidable list of languages is that Jan, in fact, is a polymath, which will become evident as I continue. So, Jan is a career technologist and is accomplished at managing software, hardware, large and small groups of developers, testers and support personnel. There's more than 25 years of experience in the networking industry. This is why I've got notes, because this is formidable. As a hands-on developer and as an engineer executive, he most recently led the Regional Research and Development Engineering Centre of the global networking giant Cisco Systems in Shanghai, China. For the last 5 years, Jan has volunteered with the DoJR as their technology advisor in the documentation of Jewish records, building a platform that allows us to manage interactions with organisations and individuals, developing partnerships in the community with potential catalogue content. He has gathered considerable hands-on knowledge and experience into creating AI models for automatic handwriting recognition. And I think this talk will leave you in as much awe as I am of the wonderful Dr. Jan Gronski.
Thank you, Estelle. Thank you all for coming here. Without further ado, I just wanted to introduce to you some of the projects that we've been working on. Essentially, this presentation will consist of 2 parts. The first one has to do with handwriting recognition, and the second one has to do with a tool that we have developed, which allows us to visually represent the places where Jewish people used to live. You will see a little bit better later on as I explain. This is quite a difficult task. So the DoJR Foundation is an organization which is based on volunteers. We have about 40 volunteers working on different aspects of it. And the objective is to make various historical and cultural materials available to general public. Now, as you can see, the AI Labs is an integral part of the organization, and it is dedicated to a problem which you, of course, will encounter if you are trying to work with older materials, because everything which was written in just about everything in the 19th century was handwritten, right? And also a lot of materials in the 20th century, especially the early part, were handwritten. And those materials are very, very interesting and very relevant to our history. So we have started a project to enable people computer is not very good with scans. It just cannot really understand. It understands the bits over there, understands the colors, everything is great, but when it comes to understand what's written on the scan, it does not understand. So you have to make this transformation from a scan to a essentially computer readable form, which is like typed form, if you wish. Why do we want to do it? Well, mainly to enable searching, right? And of course, those people who are interested in particular area of history, they can go and read it. Let's see, so a little bit of history. I've been working with this project for about 5 years, maybe a little bit more now. We started with Polish. Well, Polish is my mother tongue, so that was pretty obvious. Then we progressed to Russian. Then we started doing Yiddish, which I don't know, by the way. I've been learning a lot as we go along. And finally, last year, I've been had the pleasure of working with a former ambassador of Israel to Jordan, and we've been working on an Arabic model, which has to do with the names of the people from Baghdad who migrated from Baghdad to Israel, mainly to Israel, I think, in 1951. This project is just about finished right now, so that was a fairly quick one. But so yes, and I've been trying to learn a little bit of Arabic as well. So that's my side hobby. Languages is something which I enjoy a lot. Anyway, so we've got a really very able team that I should acknowledge. In fact, we have 2 people from Australia who are helping us. Unfortunately, they are from Melbourne. I don't have any volunteers from Sydney. If you would like to volunteer and you feel that you have the time and you are able to, please contact me. We always need some volunteers. And I explain what needs to be done. In any case, those people include people who have considerable knowledge of machine learning, languages, okay, and of course experience in genealogy. If you want to volunteer, we need people who are patient and who pay attention to detail. Okay, that's really essential for this job. All right, so I covered a little bit of this, a little bit of a focus here. We have focused our work primarily on languages which are relevant to Jewish history, which is, Polish, Russian, Yiddish/Hebrew, because they often get all mixed up together. One language which is not present here is German, which is also very relevant. But the reason for that is because there are many publicly available language models. I'll explain the word language model in a moment. And so we didn't want to duplicate that work, right? Now, one important, very, very important thing. We're here, that is in our work, we're doing transcription, not translation. In other words, we just take the scribble on the scan and convert it into typewritten form in whatever language or alphabet it is, right? We do not translate. There are plenty of tools, like Google Translate, ChatGPT, you name it. There are many, many places where you can take the text, feed it in, and they will do reasonable job. Since I mentioned ChatGPT, etc., I'm sure some of you have tried to use artificial intelligence for this kind of work. And so a few months ago, I tried to feed ChatGPT and Gemini with a scan of a 1897 Russian Empire census, right? Which had, the usual things, the names, the family name, the surnames and given names and the places and so on and so forth. And and what came out was a little bit surprising because, for example, for the name, a Russian, very typical Russian name, Kovalyov, it converted it into Gromyko. And many of you probably remember that Gromyko used to be a foreign minister in Soviet government, right? So my thinking is, the ChatGPT, when it couldn't decipher what it is, it just picked something which had a high probability that it might be it, right? It realized it's a name. So my advice is, yes, if you have some plain text, use ChatGPT or many other things like that. But be aware that you better know something about the contents of the document, because you may be led completely astray. So be aware, especially names. Names are really important and difficult. In any case, we settled on the artificial intelligence, which is called Transkribus, which it's sort of a Germanic pronunciation, because that place was developed in Austria. In any case, the reason we selected it is because it is custom-made to read handwritten and typewritten stuff, right? In other words, it doesn't have general knowledge of everything. It just knows how to decipher squiggles, okay? The important thing is that it does not pretend that, or does not invent things. It gets it the way it gets it. Sometimes we human beings reading handwritten stuff make a mistake. We look at the word or the letter and we just say, probably it's that, but we're not sure. And the same thing happens here. So I know that there won't be any hallucinations here, but it may not be 100% right, the same way as humans. Now, as I mentioned, this AI was developed at the University of Innsbruck under the aegis of European Union. Then they separated and became part of a non-profit co-op, which is called Read Co-op. And we're using it, okay? Now, I won't repeat what I said before, it's transcription. Okay, so I wanted to tell you how our work looks like, generally speaking. So if you start really from grounds up, in other words, you don't have, there's no other language model, okay, important thing. So language model, essentially, you can think about it as an abstract representation of language, of words, and the alphabet, right? And so if there's no, let's say, a pre-existing model that you could start from, for example, do you know any Sephardic people here who know Ladino? Because we would like to start a group doing essentially, but we need people who speak Ladino and who can read Solitreo and are familiar with computers enough so that they can enter the stuff into the computer. So if you have any friends who are interested in a project like this, please contact me, because we've had some difficulties in that. You know, we cannot really put together a group, and without, well, at least 2, maybe 3, or better yet 4 people, it's really difficult to get it off the ground on a volunteer basis, right? This is not a paid job, right? You just sit there and spend as much time as you please. That's it. So how does the work goes? So assuming that you have nothing, we first need to have enough materials, scanned materials. And typically you would start with 30 to 50 pages of text, depending on density, right? How many words on the page. We then feed those pages to Transkribus, right? And then very painstakingly enter word by word what we see on the scan, right? So we do really a grunt job initially. It takes a lot of time and patience. Now, what we do next is we take part of these, say 50 scans, let's say 45 of them, and we call them the training set. And then we have another 5, which are the validation set. And so what happens is we then take these 45 and have the Transkribus start working on it and try to develop something, right? And the way it works is it takes these 45 pages, each page has a transcription, which we call the ground truth, even though there may be some errors in it, but it's the best we could do, right? It compares the page to those typewritten stuff, and then creates some kind of initial model, okay? then applies it to the validation set. Validation set also will provide with the ground truth or the real stuff to Transkribus. And so the AI compares the results of its initial first model, right, to what really is supposed to be there, and says, this is supposed to be that, let me modify my stuff, and creates a next model, right? You feed it back, and then it keeps on doing it, it circles and circles, until it decides that it's not making any more progress. How does it know that it's not making any progress? You see, there is something which we call the character error rate. And what it is, it's a measure of how many errored characters or letters, if you wish, are on a given set. So on a page, let's say I have 100 letters, and I made a mistake of 10. That means that I have 10% character error rate, right? So at the end of each run, Transkribus looks at the error rate on the validation set and notes it down. Then it does another iteration, and hopefully it's getting better. Finally, it gets to the point where does not see any progress. And at that point, it stops. Okay, it says, okay, here's your first official intermediate model, language model. Okay? Now, why is it important? Because now we go into another iterative cycle. What happens is that now we take another, say, 20, 30, 40 scans, we feed it to Transkribus, have the machine, using this first model, transcribe it the best it can, then we give it to the volunteers, and the volunteers go and keep on correcting the errors that the machine made, right? Well, now it's much easier, much faster, because it gets it, it's getting better and better. And you feed it back, and again, the machine does another run, and then eventually you get to the point where you say, that's good enough. We have reached level that is satisfactory. Now let me just explain what satisfactory means to me, okay? So what we want to get to is to the point where a person who is skilled in the language can read the document, even that has some errors in it, but can easily get over those errors. You've seen it often. Sometimes there are typos or orthographical mistakes people make, and you say, nah, that's okay, I know what he means, right? So that's exactly where we want to get. Now, how do we judge it? Because I don't have an army to go and do some testing on people. We essentially use, again, the CER, the character error rate. And in my experience, once the character error rate gets below 7%, the text is legible. You can read it. You know, if you know the language, you can read it. This is just an example of one of the scans that we were working with. What it is, it's again one of the civil records. This one, I think, is the death record from a city, Elizabeth Grad, 1859. Okay, and what you will see here, an interesting thing, is that the books in Russian Empire, in Jewish communities, were written both in Yiddish/Hebrew and in Russian. So on the left-hand side, you have the Russian text, and on the right-hand side, you have Yiddish/Hebrew. Now, you'd say, well, why even bother, to translate? If I have a Russian, why do I need to do Yiddish? Aside for the fact that I like Yiddish, okay? That's good enough for me, but maybe not for anybody else. Well, it turns out that those two pages sometimes don't match exactly. You get more information if you know both of them. Sometimes we go to the Russian side and we get some more information. Sometimes the Yiddish side provides more information. And what's more, by looking at the Russian side, our volunteers found that you can easily figure out which vowels to use for given names, because that sometimes is not clear, right? It is useful to have it this way. Now, let me, before I get to show you the results, some results, I want to show you our progress here, because this project has been going on for about 2 years. So we divided our set of documents into 3 different groups. Well, actually 2 different groups, and then we combined the 2. The first one were the metrical data, which are the civil records from Russian Empire from 19th century, okay? And the second one was non-metrical data. So those were personal letters, plays, we had plays that were written by hand by their authors, community minutes from different various documents which were more or less in the form of text, right? Just plain paragraph-based text. So this is the result of the metrical data. And you see here, first of all, the time progression. You can see about 2 years here worth. On the left-hand side is the number of words that we used in order to develop the model. And on the right axis, you have the CER. The red line represents the CER, and as you can see, initially there was a big drop, right, as machine was learning. And then you have this curious bumps up and then going down. Why? Well, because we fed it new pages which were written by different people, and it had to include this experience in its model. So initially it would just bump up and then go down. As you see, the result was pretty good, under 7%, which, as I said, is what I want models to be. The other line is also a little bit curious because you would expect that this should be going monotonically up, right? We should be adding and adding, and we have those dips in there. That's me. I made some mistakes. I forgot to include some of the documents on the way, and that's why you see you have this drop over there. Yeah, you know, and we have included them later. But I just left it here just for fun. Now, this one are the non-metrical, and as you can see, I mean the same comments on the lines. And just notice that it is not as good, right? It just came out at about a little bit over 9%. Okay, that's because we have so many different handwriting styles, okay? Especially before 1920s, when Evo has standardized the way we're supposed to do it. And even then, people were still not following it. And just the children in school would learn how to do it. Now, there's an interesting thing which I want you to observe. Here we have about 9.5%, let's say, CR rate. When we combine the two, we got this kind of a strange thing. And notice that the combined model is better than the model which dealt just with the non-metrical stuff. Why is that? So I attribute, this is just my theory, is because the metrical data contain many surnames, okay? And surnames and place names are the most difficult things for the artificial intelligence to figure out. And so the influence of the metrical data, even though it was much less in terms of volume, was tremendous. And we have a very, I think this is close, it's not quite 7%, but it's close enough. And so I wanted to show you some of the results. So this is an example of a letter that was written to JDC, Joint Distribution Committee. Oh, by the way, it's something which I learned in the process here, is that the Joint operated in German-occupied Poland from 1939 to 1941. I was never aware that that really was the fact. But in fact, they distributed help. They got many handwritten letters from different communities, and this is an example of one of them. So On the left-hand side, obviously, you see the letter. On the right-hand side, you see the results of the machine translation. The red marks are the places where machine made a mistake, and the green marks is the place what it should have been in its place. Now, similar on the metrical data, this is how it looked like. The same comments, nothing special, not any different here. But you can get the feeling that once you get the model to be sufficiently powerful, you can read it. You can, you can fill in things that the machine didn't catch right. And by the way, I wanted to say, it's impossible. It's not worth it even to try to get it down to zero. I mean, that's an infinite process, and it's just not worth our time. These are just a few comments, right? First of all, our ground truth is never perfect, because we are just humans, and we look at it and look at the word and say, well, is it this letter or that letter? And we try to guess from the context, but it's not always right. Sometimes machine is better than us, okay? Especially in the case of faded letters, okay? It can read things much better than we can. With the bleed through is another problem, and so on and so forth. Of course, difficult to read handwriting is difficult for us and for the machine as well. But anyway, the important thing is to get it down to the point where normal human being can read it reasonably, with reasonable ease. Now, I wanted to say something here. You wonder how long such a process takes care, how much time do we spend on it. Now, of course, Yiddish, I already kind of told you, this was 2 years. It took us 23 iterations of building this model, Yiddish model, those 3 models actually. But if you have a sufficiently voluminous set, a very large set of someone's handwriting, you can do it much faster. And in fact, I wanted to show you that. Okay, so I'm sorry, before we get there, this is our official models, public, available to anybody who gets onto Transkribus, so anybody can use it. And as you can guess from the names, the letter reader is a non-metrical. The civil records reader is, of course, the metrical stuff, and Mameloshin is the combined. So now, getting to the question of how long does it take. We did something with a very special person, his name is Ami Eliasov, who was working, or was a student at the University of Hebrew University, and he was working on his PhD thesis. And he had this enormous Pinkas book, right? As you can see, it had 165 pages, okay? The total number of words in that document was 180,000. It took us 6 iterations, and 4 to 5 months of this one person working. That wasn't a team of volunteers. It was just Ami who was working on it. Okay, and he got it to the level that is really amazing. Look at the CR, it's 4.4. It's just amazing. Let me show you one page out of this document. I really love this handwriting. This is so beautiful. And there's like, how many, 160 pages, 70 pages of this? One person kept that book. Okay? Amazing. Anyway, so this is the place where I wanted to stop the first part. Okay? And get into the other one. I wanted to show you something that we've been working on in the last, let's see, it started in March, so now it's about 8 months. Well, actually it was finished more or less in 6 to 7 months. So the objective was here, well, we know that we used to be everywhere, but really, what does it mean? So it turns out I have a book that lists all the known places in, at least in Central and Eastern Europe, where Jewish people used to live, and also some other countries, but not as extensive. And there are 40,000 little shtetls and stuff like that. This is 19th century, sorry. I should qualify, this is not pre-World War II. This is 19th century. And so the challenge was, of course, to put those towns on the map, right? And then once I started doing this, I realized that, hey, yeah, towns are towns, it's interesting, but also wouldn't you want to know where your ancestors used to live? You know, maybe you enter the name and you will see all the little shtetls where people of such surname used to live, right? Maybe that's a better approach. So one big challenge here is, as you know, spellings vary, okay? Can you think how many different spellings of the surname Schwartz you can think? I mean, I can probably off the top of my head get 6, and there are many more, because what has happened is, of course, as we moved from one place to another, to a different country, different language, we adapted the spelling of our names so that it fits the language in which we were living. In my family, in fact, we have a very similar situation. My father's original name, right, was Geffner, okay? Now, Geffner is the same as Hefner, actually, because what happened is that Hefner, when that name, or these people, got under the Russian rule, H's generally converted into G's. Then when we get back into Latin script, the G remained in place. But there are many, many more, much more complicated transformations. I first have to acknowledge the people who did most of the work. My work is just putting things together. You know, I'm just a technician who cobbles things together. But the real footwork is thanks to 3 people. Sally Ann Sack, Gary Mokotov, and Alexander Bader. So those people were kind enough to provide me with the information that I used in creating this app. Sally Ann and Gary got the stuff from United States Board of Geographical Names, okay? And Sasha Bader just got it from wherever, you know, he just went around. Just to give you an idea, I mentioned 40,000 shtetls. That's from that book, Where Once We Walked. Now, these other 3 books, which cover Kingdom of Poland, Russian Empire and Galicia, I have 120,000 names, surnames, and variants in there. Okay, so you can imagine what a huge job it was. So here they are. Unfortunately, Gary is not anymore with us. He passed away a few months ago. But I still had the pleasure of meeting him and talking to him. And I could work closely with the other 2 all the time. Now, okay, so some of the challenges, and after that, I think I'll just jump into the real-life demo so that I can show you what it really looks like. I have a few slides in there that kind of explain, but I think it's more fun to see the stuff working as opposed to just some screenshots, right? Okay, so one important thing. Yes, I come from a computer background. I spent 35 years working in computer industry, but really, I have not coded myself, right? Well, I don't know, 30, 40 years, long time, right? And then I got into things like managing people, doing all kind of, quasi-engineering stuff, right? And so, in order to overcome that, I had to engage an artificial intelligence to help me out, right? Because for me, thing, the project, which took like 6 months to do, would have taken forever for one person of my caliber, the coding caliber. Now there are many other challenges there. First of all, those documents that I got are not always consistent. The format is supposed to be one way. Just imagine 120,000 entries in the, that Sasha Bader put together. It's inevitable that some mistakes creep in, some inconsistencies, spelling, typos and stuff like that. And software wants to have everything perfect, right? So I had to, and even, well, one solution is you go and correct those mistakes in the source. But imagine if you have 120,000 entries and you got just 1,000 errors in there, which is a very small percentage. I mean, it will take you forever. So again, artificial intelligence helped me to weed out those. And once I got to down like 30 or 40 errors, then I will do it by hand at that point. Okay? Now, there are several things while working that you have to watch out while working with artificial intelligence. First of all, it is very eager. Okay? It really wants to please you, and it behaves sort of like I say, junior programmer, that you just got out of school. It's very good technically, right? But doesn't understand really what is the long-term goal. Okay? Not only that, you tell it, and it will forget, because I don't know enough about technical background there, but I presume that it cannot keep all the information there. So every now and then you have to tell it, yeah, this is interesting, this is fun, but we shouldn't be doing because we have this thing to accomplish, right? So you have to keep on guiding it. It is extremely, psychopathic. It will praise you. So you shouldn't fall for that. Oh, yes. You will say, I make a suggestion. I say, did you notice this? Or maybe we should do this. What a great idea. What a brilliant idea. No, don't fall for this kind of crap, because you can easily, get bamboozled. Or it's not really intentional. It just wants to please, right? So you have to be very, very careful with that. Also, there's another very important thing. It's focused on the short-term win, okay? It does not think that making this kind of a compromise now, let's say reducing the number of errors here, but neglecting the implications, long-term implication, is even more important. So you have to watch out. I think that, first of all, with artificial intelligence, the number of programming jobs will be like probably about 20% of what we need right now. So people who are studying computer science, be aware. It will be difficult to get a job. Now, the other thing is the computer science departments will have to change their curriculum, because one important thing is to learn how to manage artificial intelligence, okay? It will write very good code for you, but, for example, doing things like organizing your stuff, because it remembers everything, okay? It can remember as much. Even if it doesn't remember, it can just go through 100 or 500 files that I piled into one folder and figure out what's in there. But you don't. So you have to force it to organize your code in such a way that you can remember and understand where things are, okay? So there are little things that you have to learn how to deal with them. And this is just one example. In any case, it always declares victory. It says, we have arrived. No, sorry, I'm not happy with this yet. Let's continue. All right, I think I have. Yeah, also be aware of the suggestions, because you can easily go off to some kind of unnecessary effort that you spend trying to solve a problem which looks kind of interesting, but it really does not contribute to your project. All right. The nice thing is it never gets offended. You can tell it, hey, dummy, this is not very smart to do. And it doesn't have ego. That's a plus. Sometimes you can vent. You say, you make this mistake over and over again. For example, and that has also to do with short-term memory. All these texts that I work with have accented characters, right? And in order to do this, normally you need some special arrangements. And it invariably forgets about it. So he says, oh, we've got an error here. I said, did you check? It's called Unicode, something. I said, oh yeah, okay, let's go and fix it. All right, so this is kind of a comedy of errors, unnecessary. A human being usually would remember all these things. So as you can see, you can recognize that this is really Google Maps, except that I have placed all those blue dots which represent the little shtetls over there. And if I hover over one of them, eventually, yes, it will show its name. In this case, it's Trellis. Okay, if I click on it, you'll see something like this. And I'll go into more details later on. But let me point out here is that it shows its coordinates, the distance to the nearest important town, okay, where it is now, in which country, in this case it's Belarus, and population, which is somewhere in the end of 19th century, Jewish population, by the way. This is not general population. We have also here sources where the information was, there's no sources on this one, I'll show you them later on, that was gotten from. This is probably just the information from USBGN. So, these two other places I'll talk in a moment about those two buttons here. So, typically the place where the control of the entire app is in this, what we call the hamburger menu. And there are 4 commands in here. Search surname, so that's pretty obvious. You just go and enter the surname and you'll see in a moment how it works. Second one is find similar names, because remember we were talking about how different names are spelled. It's not uniform, there are many different ways. Then you can just simply search for a town, so that you can find on the map where the town is. And finally, the last one is very technical, but it has to do with the representation of how a surname is represented in the system. In other words, how it mainly is for debugging things, but sometimes some people like to play with this anyway. So let me just show you how this works. And I chose a few, just because of the limits on time, I cannot go through everything. So let me, I think I remember, okay, again, right, this one. Yes, okay, I chose a very unusual name. If I chose cats, it would just say all over Poland, big deal, right? So don't even bother. I chose that unusual name, first of all, because I never heard it before. And here, on this little informational window, you can see several things. First of all, you see the name repeated, and then the places where people who bore this name used to live. So let me first click on Adevin, because there will be some information there explaining where this name comes from. So you can see that the meaning of that word was rich and powerful people, essentially. And you can also see here in blue other names which were derived from the same word. Some of them sound the same, like, Aderin, but there are some which are some slight variants. So, the Kadirovich, both of them are more or less Kadirovich, and they sound different. And the reason I mention that is because if we enter, for example, let me open another one, like I said, find similar names, and I put in Adirim in here, then what you will see is that I only found 3 of them, you know? Why? Because phonetically, as it sounds, they are the other 2 are very different, even though they share the same root, okay? So let me just close this for a moment and continue with this panel here. So I chose this city, which is called Zarasai. That's a current name of a city in Lithuania, okay? And here we have the familiar panel now. First of all, let's look at the sources, because this one has a whole bunch of sources. And if I click on one of them, I don't know, let's choose some. Okay, so this one, it explains which document the information came from. Okay, so it has the name and a little bit of the description of where the place, where the information came from. Now, so let me close this. And then here you'll see the alternative names for that city, because names changed. In fact, in the Russian Empire, this place was called Novo Alexandrovsk. Okay, but now under Lithuanian government, it's called Zarasai. Okay, you wouldn't have guessed. Very, very different. That's the microphone that's causing the echo here. Now, another piece on this panel is the district surnames. Before I go there, let me just explain. Because Sasha Bader faced that problem. If we, Jews used to live in shtetls, but they also used to live in small villages. So long you were sufficiently close to the shul, you could walk during, to pray, that was good enough. And sometimes you had, 1 or 2 Jewish families living in a small village. It wouldn't qualify as a shtetl, but there were many, many of them. So Sasha decided that he's not going to list names, surnames per town, per shtetl, just per district, because otherwise the book that I have, for example, on the Kingdom of Poland, is 500 pages big, and I don't know whether this is an A2 format. It's like this, It's a huge book. He would have had like 3 books like this just for Kingdom of Poland. So that's why this is on the district level, not on the town level. So if I click on this, hello, oh, there it is. Okay, you see the list of surnames of people who used to live in that district, right? Of course, you have the other, which is conveniently here at the top, because it starts with A. But you could type in something and search through this and see if there are any names which contain an EL syllable. You can see that there's a whole bunch of them. And if you click on one of those, it will bring you again to the surnames search panel, and you can search where Gimmelfarts used to live, etc. Right? Okay. Now, one thing. Let's see. Okay. So now I wanted to show you another thing, which is searching for towns. So we've been already into the find similar names, but searching for town is also interesting because, let's see, let's pick a name, I don't know, let's take Kalisz, just because I'm from Poland, so find, filter Kalisz, and what you will see here is a bunch of names that contain the word Kalisz, including Kalisz Gubernia, right? Because in the 19th century, this was part of a larger entity. Of course, this is not a town, and if I click on it, it will just tell you, sorry, this is only Gubernia, and we're not going to show you anything about it. Now, on the other hand, you can click on Kalisz itself, it brings you to this place, okay? And you see the familiar panel. The one important thing which I wanted to show you is that once you click on the name of the town, the map focuses on that town. So you can see here different blue dots, okay, in the Kalisz area. So one of them, the one, I think this one, maybe, no, this is not this one, maybe this one. Yes, this one is Kalisz, right? But this one is probably a small village that currently was incorporated into the Kalisz city, right? So again, I could go there, and really it's a section of Kalisz nowadays.
I can't thank you enough for giving up a Sunday morning
No,
to come and speak to this
my
group.
pleasure.